So I think we can start. Hello, everyone. Good evening to our 6th EMEA Online Meetup. This time the topic is Docker for Data Science, another tech special. We had a tech special a few weeks ago, which was hosted by Christian and me. And today we are going to have a deeper look into Docker for Data Science. For all of you who attend the first time, this is usually the agenda we have for this kind of meetups. First, I'm giving a little intro, which I'm doing right now, and then we'll have a 10-minute slot for community discussion, where we can discuss recent news or something you want to discuss on projects or on the courses that we are doing on TWiML. And then I'll start with the main presentation, and the presentation and question and answer is a slot for like 45 minutes. And on top of the hour, we will close the session. The next EMEA meetup in April is going to be on Oneshot Learning, which is going to be presented, pretty sure I'm not going to speak this out correctly, by Samujwal. I don't know if he's here today. And if you want to present a paper on this meetup, on this monthly meetup, or if you want to propose a tech special, then you can just reach out on Slack or LinkedIn or email or wherever you find me, and talk to me. Yeah. Then the Fast AI.
So Kai, it might be an idea for you to try and just mute everyone if you can.
Yeah. Oh, wait a second. There's some background noise, right? Is there a button to mute everyone? I don't know.
There is.
Maybe you can unmute you can mute yourself if you hear that. Okay, much better now, I think. Awesome. Yeah, the Fast AI V3 Part 1 study group is progressing. I think there are some people here on the chat that know much more about it. Christian, for example, or anyone who's participating. Maybe someone can say some words where you are and how is it progressing?
I was skipping the lesson, so I don't know.
Okay.
Sure. So we're progressing. We're on lesson. So on the coming Saturday, we're going to be on lesson 6.
Okay. Well, that was fast.
Yeah. So there's a group of about 30 to 40 who join every Saturday, and so it's coming
awesome. Awesome. Very big group. Nice. Nice to hear that.
So we're getting ready for the part 2.
Yeah.
Because the part 2 was announced, and it's not open to everyone as was the live for part 1.
Yeah.
We kind of decided that only people who kind of active on the Fast AI forums get access to live.
Michael, can you speak up a little bit or turn on your microphone a little louder?
Yeah. Can you hear me now?
Better.
Is it better?
Yeah.
Yeah. So I was just saying that we're also getting ready for the part 2 of the course as a study group, and so the part 2 also is going to be live, as was part 1, although it's not like open to everyone. Jeremy selected to only give it to people who are active on the forum, Fast AI forums. So that's kind of now as a requirement to be in the course. But our study group will be, I guess, open to everyone who wants to join.
Oh, interesting. And do you know what's the threshold for being active on the forum? I think I got an invitation.
Yeah, I think it's like 10 likes or something.
Okay.
Oh, really?
Okay. Interesting. I did not know that. Luckily, I had one post that got some likes, so I got the invitation for that.
Yeah.
Interesting. Did not know that. Yeah. Okay.
He said 10 likes or people that were from underrepresented groups.
Okay. Yeah.
Okay.
Yeah, they are. Yeah. Okay. Interesting. So there are probably some people who got no invitation for that here on the group that want to participate.
Yep, it's me, one of them.
Okay, interesting. And did he say if it's okay or not okay to share the links inside of such a group?
I think we are not going to share the link, but I'm not sure about the study group in TWiML, whether we are restricting or not. But obviously, that's the code that whoever got selected won't be sharing that the link URL.
Okay, so maybe it could be it's a good idea to ask him if we can share the video links inside the TWiML group. So I guess he knows that those people are active, although they are maybe not very active on the forums. We are active inside this group, so maybe he's going to allow this. That would be a good thing. Would be, I don't know. It would be sad if someone in this group here is left behind because he did not post on the forums. Okay. Okay, so if you have any questions during the presentation, you can just unmute yourself and ask me, just interrupt me and ask me. That's absolutely no problem. It's going to be a more interactive session than a paper presentation. If you have any question that you just wanna post, then submit it via the Zoom chat. Maybe someone of you, Michael or Christian, maybe can watch the chat and forward the question to me if someone asks something. Because I'll probably not have the time to look into the chat.
Yeah.
And awesome. And yeah. Okay, so now time for the community discussion. So we already discussed some things about the course. I think OpenAI's GPT-2 is probably something that that we can discuss because it's something you cannot get around these days. Does everybody know what GPT-2 is? I guess most of you heard about that. So what are your takes on this? Does anyone have an opinion?
Yeah, so the examples on that blog, they look pretty good, scary good. But they've kind of like handpicked the good examples because the model kind of generates at the moment 50% roughly of kind of good output. So it's still to be kind of handpicked to kind of show what it's capable of. Of course, they didn't open source the full model for some worries that it can be used to some wrong reasons.
Yeah.
So that kind of was a big discussion on Twitter and in the internet, I guess.
Yeah, that's interesting. It's interesting that that OpenAI is doing this because I thought if someone's not doing that, if someone's would open source such a model, then it's OpenAI. And I personally think that I mean it's probably slowing down the process of someone recreating this model, but I don't even think that it's going to take a long time. Until someone is going to recreate this, and
that's what I thought. I mean, I didn't follow the details, but it's a bit stupid to kind of in this early stages of all this AI stuff to kind of not release it because there's so much development. Something better or more dangerous will come along anyway. So I don't know what that's supposed to.
Yeah, I mean. I get where this is coming from because I mean this kind of models, especially in the times we are living, it's very powerful. It's a very powerful model that you can use to create kind of automatically create disinformation and stuff. And I get the reason why they're doing this, but I also would agree that it's not the correct way to not open source this model.
Well, I thought it applies to fake video and fake photo stuff anyway. So I mean, this stuff now.
I thought the argument was that they could recreate the model with around $50,000 worth of computing power, and so the argument was that this, for anyone that it matters for, this doesn't make a difference, and then all it does is just hurt the little people. So I was
Yeah.
more on the side of the NVIDIA person that was part of the TWiML chat or round table that was saying, you know, we need to be open. This is not the time to close it down, and we reduce our abilities to create countermeasures if we don't know exactly what the deal is.
Yeah, absolutely agree with that. And Jeremy posted one tweet where he kind of compared this to a zero-day threat in computer security. Actually, I didn't completely understand what this means, because in this kind of zero-day exploits, so someone is discovering a threat, and then this threat is just discussed with the people that concern this. So, for example, if you find a zero-day threat in Windows, you will discuss this with the people from Microsoft. And I did not really fully understand how this could work for this kind of model. Does someone have an idea how this was meant? Okay. So, yeah, I don't know. It's
Kai, I have a question. I didn't really get this GPT-2 model. Is this some kind of natural language processing algorithm that can sort of
so
what does it in essence do? I didn't get that at all.
There's
so maybe we should roll one step back and start there.
Sure. So there's probably someone here who's definitely more details on it. Cal, you just said that you heard the TWiML talk, so you definitely know more than me. Maybe you can say a few words on the model. So I know that it's a language model that can auto-generate language, and it's really good at doing that.
Yeah, so I think the idea was that it wasn't so much of a new implementation. It was just a broadening of the scope and the extent of a text generation system. And so what they had done is they had run and kind of like inside the OpenAI development team, you could pass it different segments of text, and it would kind of generate a narrative based off of that template text. And so they gave kind of 10 different examples of, there's I think one of the examples was like, there's the unicorns are real. And then it would kind of go through and it would generate an entire story. And then they published only a select amount of that. And it was based off of what the reports were, is that it was just kind of unbelievable how much sense it made. And so the idea was that someone could take, a sentence of fake news and then generate an entire article based off of that. And so they had people from OpenAI, they had two ethicists from OpenAI that were talking about that this was more of a start of a discussion of how we should protect some of these models to at least give people the opportunity to see, okay, how could this be weaponized for bad things? And then there was other people that were there was someone from NVIDIA that was more on the side of, hey, this needs to be open. This is not the ability to the code is already out there. This is not a leap forward in creating a new model. And so if someone wanted to create GPT-2 from scratch, it would only cost around $50,000 of computing power. So state actors that could weaponize this for fake news, kind of what they're saying with Russia, could do it easily. And then OpenAI kind of came back and countered with, well, we're going to work with, if people want to kind of apply to be able to test the model to see what it's being used for, then they could do so. And then NVIDIA kind of came back and countered with, well, that's part of the closed down process that we don't want to start doing with machine learning, is that, now you have to apply to be part of this, and creating barriers. So the idea was like, is now the time to start creating barriers for AI, or does it need to be open? And then the counter argument of, if we had the code and we could do this, then there's also the ability to create countermeasures to recognize when fake news or automatically generated speech or automatically generated text is created. So it's kind of a double-edged sword.
Yeah, I mean, I think the Russia example is really good. $50,000, that's nothing for a government. And it's absolutely completely easy for them to recreate this model and use this. And all the other people doing research on this cannot spend $50,000 on this, and they will not have this model. So I'm definitely on this side of making it openly available.
I have a couple of thoughts regarding this. First of all, there was a couple of years ago, there was a Twitter account called Tay or something by Microsoft that was kind of a natural. What's the difference then between this type of thing and this GPT-2 model? Is GPT-2 then even better? And
I think
the second. Start.
Yeah, I think what Carl just said, the most compelling thing about this model was that you can give it like one sentence, like this kind of unicorns are real sentence, and it's creating a whole really good story around this, why this is true and why.
Now I see.
Wow. That's okay. And probably very, very powerful when you want to spread fake news, because you really just have to create this short sentence and then create a whole story around this.
Okay, now I see. Yeah. Mm-hmm.
Yeah. So that's the reason why they said this is dangerous. Yeah.
But then dangerous, that this, I guess, more of a political kind of thing. With all of these fake news and so on. I mean, I have the belief that people actually can look it up for themselves, and when you're doing some very ridiculous sort of fake news with very ridiculous sources and so on.
What do you mean? Something like flat Earth, maybe?
Yeah, something like that. Or
yeah, but I mean, people are believing in this stuff.
Yeah, so. That's what I've read stories about. Like in India, there is this whole social media craze, and then people got killed and so on. But what I always ask myself is this: why don't you cross-check? And I have sort of faith in humanity that the stupid stuff gets sorted out, and that's why I don't really kind of.
Well, I have the feeling that
the point in quote-unquote fake news.
Yeah, I have the feeling that the past few years and the next coming years will prove you at least a little wrong. I don't know. I hope that this is true, but yeah, I mean, people who are telling this stuff are getting louder, I think. But we have to start now. We are already 5 minutes late, so in order to go for the Docker stuff, we'll have to start now. Yeah, so let's go for the main presentation. Okay, so first I want to talk a little bit about who should and who should maybe not start using Docker for data science workflows. Personally, I think it does not really make sense to start using it when you're just starting with data science or AI. I mean, there are plenty of really good full service, batteries included providers like Paperspace or Colab to get started really fast with data science and machine learning. And I guess you should really focus on learning data science instead of learning how to use Docker in the first as your first steps. And even if you have a dedicated deep learning box at your disposal, I would suggest that for the first steps you just install everything directly on the box instead of using Docker. But that's only my take on this. If you are already more experienced in data science, or you maybe come from a DevOps or software engineering background, then Docker can be a really good way to improve your workflow. Yeah. So this is what we are going to talk about today, and what I'm going to show you. First, I will give you a little introduction of what Docker is and how it compares to virtual machines or virtualization. Then I'll talk about what containers, what images are, and how they differ. And then we'll talk about where you can get images and how you build images. And then we'll build an image ourselves with data persistence and a development installation of FastAI, which is really, really easy. And then when we have time, we can talk a little bit about what other use cases for Docker and data science there are. All right, so
it's not a big deal, Kai, but if you could maybe make the full screen, the presentation, maybe that will help for...
Yeah, I'll make it a little bit of... I have to switch between the windows, so...
that's fine.
That's okay? Can everyone see that?
It's good from my end. Thank you.
Okay. Okay, so what's the difference between containers and virtual machines? They both kind of emulate an operating system.
Oh my gosh,
which, whoops, someone's talking here. Just muted. Okay. They both kind of emulate or simulate an operating system that is encapsulated from the host system. And with virtual machines, you have the host operating system installed on a bare metal machine or on your computer. And then on top of this, you have a software that's called supervisor, a hypervisor. And this one is managing the virtual machines. And each of these virtual machines is a completely emulated encapsulated computer with an operating system of its own. So the overhead is pretty good. You have two completely independent machines running on your machine, your host operating system and the complete guest operating system. And also the virtual machine on which the guest operating system is running is a predefined computer, which means that you have to define the size of the RAM and the number of the cores before you are using it. And that's okay for a lot of use cases. But when you want to use a virtual machine on your computer for data science, that's not a good idea, because when you do that, you just do not have access to all the resources of your computer. And that's usually something you want to have or you need for data science or machine learning. Containers, on the other side, do not have this kind of restrictions. Instead of emulating a whole operating system, it's only an isolated file system. And it's using the same operating system kernel like the host system. So simply spoken, a Docker container is just a file system sitting on your hard drive using the same kernel like the host system. And that means that there's practically no overhead. And if needed, the container can use all of the resources of your host system. So let me quickly show you what I mean by that. So you can see my command window here. Okay.
Can you increase your font size?
Yeah, sure. Like this? Better?
Maybe a little bit more even.
Yeah, wait a second. I'll make the screen a little bigger. Like this?
I think that'll do, for me at least.
Okay. All right, so this machine here is my workstation, which is in my office. Let me connect this one too. This is a Linux machine. And on this side, I will bring up the system monitor so you can see the system resources here on this screen. And on this screen, I will fire up a Docker container. I will show you how this works during the presentation, but I will just quickly fire up a container. This is a Docker container containing PyTorch, which is coming from NVIDIA. And then, so first look how fast this container is starting, and then also have a look at the system resources, how much system resources it uses. So it's already there, it started. And as you can see, there is basically no overhead, not even 100 megabytes of RAM additionally for this container. And I'm inside this container here, which pretty much feels like any virtual machine or any computer you would have. So that's a really cool thing. All right, so let me go back to the presentation. Yeah, so the container is an kind of an isolated portable execution environment, which pretty much feels like a virtual machine. But it's powered up way faster and it's more resource efficient. And we need one more addition if we want to be capable of doing deep learning, and that's the GPU. And by default, you cannot use the GPU inside a Docker container. So we additionally need the NVIDIA Docker runtime, which is provided by NVIDIA, and this is passing the GPU from your host system through to the container. That is actually pretty cool because the only thing you have to do for yourself is installing a proper graphics card driver, and Docker and the NVIDIA runtime, of course, and all the other libraries, all the other stuff is installed inside the container. So when you use a pre-built image, like the PyTorch image I've shown you, you only need to download and start this image, and you are ready to go. No need to install any CUDA stuff whatsoever. It's already done by someone else. When I started this container, you can see that it did not found any GPUs to use. So this is because I started this with Docker run. And if you have the NVIDIA Docker runtime installed, you can do NVIDIA Docker run. And then you do not see the error message. And I will prove you that I have access to my GPU from inside the container. Doing import torch. And then I will check if there's any device. Yeah, there is a device, and I will just execute this here. Yeah, this is my GeForce GTX 1080 Ti, which is installed on my workstation. Awesome. So I can also show you the NVIDIA SMI tool. And yeah, there it is. Here's my graphics card. Great. So how does this work? Oh, one more thing. I often get asked if this also works on Windows or Mac, because you can use Docker on Windows and Mac. Yeah, I'm muted. You can use Docker on Windows and on Mac, but the answer to this, if you can use this GPU stuff, and if it makes sense to use it for data science, is unfortunately no, because when you use Docker on Windows or Mac, it's really just a Linux virtual machine with Docker installed. And you have all the disadvantages of a virtual machine. Inside, I can show you this here. I have Docker installed on my MacBook here. When I go to the preferences in the advanced tab, you'll see that these settings are for the virtual machine. I can say how many CPUs it should use, how many cores, how much memory you should use, and yeah, that's the virtual machine underneath the Docker. There are native Docker containers for Windows, but I don't think that it's possible to use it with GPU, at least not on the classic Windows. You have to use Windows Server for this. And I never really tried this, so it probably is possible, but I don't think so. And I did not try this. So I would stick to Linux for this. Okay. Let me have a look into my notes. I forgot anything. Okay. So let's go on. So I was talking about containers and images, and that's something I want to explain now. The container is the running thing I just showed you. It really feels like a computer of its own, or like a virtual machine, but it's really just an isolated environment using the same operating system kernel as your host system. So the only thing is you need Linux to have this. There is no way around Linux for this. But you can use any kind of Linux. And the container is a running instance of an image, which is kind of a blueprint of how to create a container. And those images are built in layers. That's pretty cool, because when you have a container, for example, so let's say this container is built on Ubuntu 18.04, then you have 10 other images that are built on this Ubuntu, then it's only stored one time on your system. So you have only one time this layers that you need to build this. And that's actually pretty cool. It saves a lot of disk space here. So maybe you can think of images on containers the same way you think about classes and instances of a class. The class itself is the image, the blueprint, and the instance is the runtime object of this class. Okay, a lot of infos. Are there any questions so far?
Yeah, Kai, just a question around the the Windows. If you download Docker for Windows, you seem to suggest that was the same as having a VM, but you don't have the hypervisor of a VM. So why is that? Are you saying that having Docker for Windows, and I get that you're just having a Linux guest OS on top of that, are you saying you can't get the full benefits of Docker if you run it on Windows?
Yes, absolutely. That's true. There is a hypervisor. Yes, when you install Docker on Windows, it's also installing in the background, I forgot the name, or from Oracle, the virtual machine. What's the name? Does anyone have the name?
VirtualBox.
Yeah, it's installing VirtualBox in the background. And then it's really just starting a virtual Linux machine, and inside of this Linux machine there is Docker installed. So using Docker on Windows really only makes sense for development purposes. So if you, for example, develop some kind of web service, then you can use Docker for Windows just for testing your code or writing code and then testing it, looking at the web page you just created or something like this. It definitely does not make any sense to use Docker for Windows for deployment purposes or for data science purposes because you do not have access to all the resources. What you can do is have it on your Windows machine or on my MacBook, for example, and use it to code and test your code inside of this environment. But you would not, or maybe you can use it for some easy modeling. So when you build some kind of, I don't know, tree model or something, which is not very demanding in terms of computational power, then you can maybe use that. But it's more, on Windows, more used for testing your code. And then when you're ready, you are deploying this, for example, to an AWS instance or to your workstation, and then let it run to train the model, especially when you do deep learning stuff. When you do deep learning inside of a Docker virtual machine or on a virtual machine and Docker on Windows, it would take ages if you train a model because it's using only a fraction of the CPU power, not even the GPU.
Kai, just relaying from the chat, I kind of answered that, but maybe for everyone, the question was if you can run notebooks inside Docker images, and I said basically, yeah, you can just map the ports, or you can access the Docker environment and link your host system to the Docker.
Yes, and we'll do that in a few minutes. In a few minutes, we'll create a FastAI image, which is using the Jupyter, where you can use the Jupyter notebook. That's absolutely possible. Okay, so let me just show you a few things. I'm gonna exit the container here. So I'm just going to show you a few commands to work with images and containers. So when you type in Docker images on your command window, you will get a list of all the images you have on your system. As you can see, I have a few images here. When you just install Docker, there will be no image. That are all the images I use. Let me make this a little bigger, so it's going to be a list. Yeah, as you can see it here. And that's to show the images you have on your system. And when you do Docker PS, you will get a list of all the running containers. So each of these containers is a running instance of one of those images you have here. And yeah, I just showed you how to start a container. You can use Docker run. There are plenty of options you can use with Docker run. The options I use here, for example, this is the option interactive, which means that I want to start the container and I want to end up in the shell of this container. When you're not used to this, it's just starting in the background. So all those containers are running in the background. The --rm flag tells Docker that it should remove the container when I stop it. So when I exit the container, it's deleting the container from my system. And this is just the name of the container that I started. And you can also log into one of those containers that are running here. So when I use docker exec, which means docker execute, then again, interactive, because I want to end up in the shell of this container. I have a NVIDIA container running here for a few hours now. So I'll use that one. Then I have to give it the ID. This is the container ID. Each container gets a fresh ID when it's started. I only have to type in the first few digits of this ID because it's going to autocomplete this. So E2 should be enough. And then I want to end up in the shell of the container. So I have to give it the command bin bash so that I end up in the shell of this container. And there I am inside of this container here. PyTorch container, so PyTorch should probably install it. I hope so. Import torch. Good. So let's go out to container. Okay, so that are just a few commands. There are a lot more commands, but just a few commands to get started with images and containers. All right, so let's have a look into my notes. Okay, so next step. Where do I get these images? There are basically two ways to get an image. You can download them and you can build them. And the biggest repository to download images is probably Docker Hub. There are thousands of images for every purpose. And pretty much every project you can name nowadays has a Docker image. Let it be Anaconda, Spark, Hadoop, RStudio, Shiny. Everyone is publishing Docker containers for their projects. So you can really just pull those containers, and then you can use this pre-defined, pre-compiled container for RStudio, Hadoop, Shiny, or whatever project you want to have. Let me show you how this works. You use the command docker pull. And when I do docker pull, I will just download a Ubuntu image. Ubuntu, let's say the newest one, Ubuntu 18.04. Then it is, yeah, you can see it's downloading all these layers. That are the layers I was just talking about. I have an extremely fast internet connection on my workstation, so this was pretty fast. And now when I type Docker images, you can see that somewhere here there should be a Ubuntu 18.04 image that I just downloaded. So that's really easy. Okay, well, let's go back to the presentation. If you want to use GPU-enabled images, then the NVIDIA GPU Cloud is awesome. I will show that to you on the next slide. It's unfortunately proprietary. You have to sign up for the repository, but they really have awesome images for sure. You should watch out for official images. So when you want to use, for example, a Ubuntu image or Anaconda image, you should really use the official images for that, because I mean, it's potentially a source for malware. If you download some published images where you don't know the author, then you can potentially get malicious software on your computer. Also, mostly you choose a base image like the Ubuntu image, and then you build your own image. And I will show you in a minute how this works. Yeah, the NVIDIA GPU Cloud. It's not a cloud provider. The name suggests it, but it's not a place where you can get cloud services. It's really just a registry, just like Docker Hub, where you can download GPU-enabled Docker images. You have to sign up to do that. Just go to ngc.nvidia.com and sign up. And once you're signed up, you can generate an API key. I think I have the site open. Yeah, here it is. So you can just go to configuration when you're signed up and then get an API key. And that's the key to log in. And when you have this key on your machine, you just do docker login nvcr.io. And then you have to type in this username. Pay attention, you have to write this for the username, including the $sign, and then the password is the API key. And then you are logged in. And here in the catalog, you can have a look. There are really a lot of different images you can choose, not only for deep learning or machine learning, but also for high performance computing and all different stuff you can do for you can do with CUDA. Okay, so let me have a look at learning and then maybe PyTorch. So when you click the pull button here, it's copying the command you need to pull this image to your computer, and then you can just paste it in your command line and it's going to pull this. I think I have this image. I already have it. I hope so. Yes, I have this image here. So I download it to my computer. And that's a PyTorch image, the newest one. So 19 is the year, 2019. And 02 is for February. Okay. Any questions? Awesome. So, yeah.
Just one question, Kai. So why would NVIDIA not make this available? Why are they putting this behind this having to sign up and so on?
I guess NVIDIA is not the open source company. There are some proprietary optimizations they are doing for these containers, and they don't want to open source it. And you can download those containers and you can do whatever you want with it. What you cannot do is redistribute them. So you cannot build an image, so you cannot build a fast AI image out of this and then redistribute it for other people, unfortunately. I mean, I guess it's just the NVIDIA policy. So they say they're doing some proprietary in this kind of images. But it is possible to install a free version of CUDA, and there are some CUDA-enabled images on Docker Hub. So it is possible to use CUDA without these NVIDIA images. But I mean, I also don't like that they don't open this, but they are really good, those images. It's really easy to use them, and everything is installed, everything is working, no hassle. It's just really easy.
Right, and are those CUDA images ones by NVIDIA or are they unofficial ones?
On Docker Hub?
Yeah.
Yeah, they are unofficial. I think NVIDIA has some open CUDA images, but there are a lot of images. There are fast AI images, for example. I've seen fast AI images for the previous version of the library. I think there are some free versions of CUDA which you can use with CUDA. I really don't know if there is a difference in performance on that. But when you, for example, would go for deploying any service that uses CUDA, I would definitely go for this kind of images, because you definitely know those images. I mean, they are built by the people who are building CUDA, and they work for this, and they are optimized for this, and yeah.
I don't think there's any harm in using them, because it's only a bit of a hassle to log in to their kind of cloud thingy there. But if you don't distribute it, you can do whatever you want with them, as far as I know. And
and of course, if you say I just want to use open source, I can understand that. And
but
unfortunately, it's not open source, but yeah.
but neither are the NVIDIA graphic cards drivers, right?
Yeah,
so.
Sure. Yeah.
So is the use case for this if you have multiple users that are wanting to do development? Because I was thinking you mentioned the Conda, the different environments. So if I was a single user, then I would use Conda if I was developing different apps.
Yeah, maybe. Okay, let me just skip to the last slide. There are some advantages you have when you do that. You never again mess up your computer, for example. I personally tend to fiddle around, try stuff, and I often break things. And that means I have to spend hours to fix it and reinstall everything. So this is a very good way. You only have to install the drivers, the GPU drivers, and the and Docker, and you're ready to go. You can start the container. You can go for it. And that's probably my most important reason to do this. Also, you can use this kind of environment and directly port it to an AWS instance, for example. So you try it on your workstation, and then when you need more power to train the model, for example, you can just deploy it to AWS as it is, and you don't have the hassle of comparing the two environments. Also, when you use different environments, so you want to use PyTorch and TensorFlow, and you need different CUDA versions, that's a really good thing because you don't have to install this on your host system. It's inside the container. You start the container, and then you stop the container, and it's gone. And you start the container again, you have the other environment. You can, in parallel, use these different tool chains. That's also one important reason. So I used to use R and Keras, for example, and you have different dependencies for that. I couldn't use it parallel on a system where I also use FastAI. So this is the solution for this. I can use it in one container, R and Keras, and in the other container, FastAI, with different versions of CUDA. Also, reproducibility. If you want to share your work with someone, it's portable. If you want to switch computers, just like I said, switch from your laptop to your workstation or to an AWS instance, you can basically, with one container, have all the different stages. Okay, so
another question for you guys.
Yeah, sure.
You talk a lot about about VMs and versus Docker.
Mm-hmm.
Is there, and VMs are quite heavily embedded in most IT enterprises. Is there any instance where you have to use a VM because Docker won't work? I mean, why are VMs still popular?
I think VMs are popular because they are, so VMs, in my opinion, are used to distribute the infrastructure. So you have a server, and there is your host system, and you have like 10 virtual machines on this. And then the overhead does not play a big role because you want to give someone this virtual machine with a dedicated amount of resources, and then 10 people can use the server. And I think people often say that Docker is the next iteration of virtual machines, and you don't have to use virtual machines. You can deploy your web services on AWS directly via containers, so you don't have to use a virtual machine. There is no use case in my mind where you have to use virtual machines. You could always do it with with containers, I think. I mean, someone can interrupt me, and I'm definitely not a DevOps guy, but
yeah, me neither. But maybe it's just closer to the old DevOps way of doing stuff. So licensing and stuff like that is probably more compatible to the previous.
Yeah, probably.
Stuff.
There's also probably a lot of legacy.
Yeah.
But I mean, when you're talking about modern microservice architectures for web services, for example, I think the way to go would be Docker containers here. But again, I'm really not a DevOps guy, so maybe there are some reasons I don't have in mind. So I'm really just using this for mostly on my workstation, and for that are different reasons of using that for this kind of workflow.
Yeah, there's a comment here in the chat, which is, I think, very valuable. I think there's some security concerns with Docker that you can rather easily break into Docker images, and I think it's probably the virtual machines are probably more isolated potentially. So
that's possible. Yeah, that's absolutely possible.
Because basically you can easily be root or you always are root in Docker, right?
You don't have to be. But actually, if you deploy something, you shouldn't be.
Yeah.
I'm always root inside of this Docker containers because I'm really using this as a replacement for virtual environments in Python. It's a kind of conda or virtual environment on steroids.
Mm-hmm.
Okay, so it's already pretty late, so let's have a look at how to build an image. So in order to build an image, you have to have a Docker file, which you have to write. This Docker file, in the first line, it contains the base image. So in this case, I want to build a Docker file which originates from the Ubuntu 16.04 image. So I'm taking the Ubuntu image, and building a new image on top of it. And then when I have this Docker file, I have to execute this docker build command. It says docker build -t for tag, and this is the name of the image I want to create, my Ubuntu version 1.0, and the point indicates that you are in the same folder than the Docker file is. I'll not go into detail on that, but that's actually pretty important because that's called the build context, and everything what's inside this folder is going to be zipped and copied into the first container that is created during this build process, and you can access all this stuff inside of the container. So when you have any scripts you want to execute, those assets have to be inside of this folder. You can give labels here, for example, the maintainer label, and then, during the build, the run commands are executed inside inside the container that is started from the Ubuntu. So what's happening by starting the build process? It first downloads the image if it's not already on the system, and then it starts the image, starts the container from this image, and it basically just parses the commands here into the Docker file. And those, if you have a look at this, those are really just normal, ordinary Linux commands: adding a user, creating directory, changing the rights for this for this directory, adding a group, and also in this command I am doing apt-get update and installing some packages. And oh, by the way, for each of these run commands, a new layer is created. So if you're writing a Docker file, do not just run each line. It would also work if you run this line, run this line, run this line, but you would always create one new layer on top of this on the base image. So you have to kind of think about how you use this run commands. And then when all the commands are done, it's saving a snapshot of this container as a new image, so as a new blueprint to start new containers from it. And then you can just use the docker run command, just like I've shown you, and start the start a container from this image. Okay, so I mean that's no rocket science involved here. Okay, so let's have a look on how to build a fast AI image out of that. I will have to rush through this a little bit, but what we want to achieve is a fast AI image that uses the NVIDIA PyTorch image. That's the image that I already have shown you. We want to have a developer installation, so the fast AI library, the code of the library should be on the host system and mounted into the container. So you can mount folders of your host system into this container. So when I work on the code on the host system, then it automatically changes inside of the container. So it feels like a pip editable install. You can use git pull on this in this folder to have the latest stuff from the repository. We also want to have the lesson notebooks and data mounted into this container, and we want to have a permanent configuration. So when we change some options of our Jupyter notebooks, it should be permanent, because when you stop the container, everything inside the container is deleted. Oh, by the way, you can also start a container and stop it, and then start it again and start from exactly the same point. You can also commit changes to an image. So you can open up a container, make changes, and then commit this to an image. I usually don't do that because it's not reproducible. You cannot, after some time, you cannot follow what you have done inside of the container. It can be pretty nice when you install new stuff and have it later on, don't have to include it into a new Docker file, but you really at some point lose what you have done and you can't recreate this anymore. So all the benefits are gone. Okay, so this is how the FastAI Docker file looks like. It's really a small image you have to write here. So I'm pulling the newest PyTorch image. I want to have PyTorch. Giving this label here for maintainer. I am changing the working directory into the root directory of the container, and then I'm running these commands here. It's really just clone the FastAI library, going into the directory, run some tools that FastAI is providing if you clone the repository. It's just a shell script. Then I'm doing this editable install. So I want to have the development installation. You can just pip install. You don't have to do this editable install if you don't want to work on the code repository. And then I am creating a course v3 directory where all the notebooks from the course will go, and also a config file for the Jupyter notebook. Because I want to have this permanent configuration. Okay, now when I'm already inside the folder where the Docker file is. So when I do docker build -t, I will call it my FastAI. And the dot for the current directory, and press enter. Yeah, that was extremely fast, but it was only that fast because I already built this image. I built it just a few minutes ago, if it is not on your system, it would download the image, the base image, and then do all the steps here. That takes some minutes, and then you have the image there. And then when I do Docker images, then you can see the, where is it? Yeah, it's the first one here, my FastAI. So yeah, you can see I built it 2 hours ago. Okay, so now we have to run this image, and let me show you. So in this folder on my workstation, I have the course v3 notebooks. I have a data folder where I can put in data, images I want to use, and the FastAI code folder, and also a Jupyter notebook configuration file. And I want to mount this into the container. And the usual way would be to say docker run -it for interactive, -rm, and then I would have to say -v for volume, and then I would have to type the folder inside the container, double point, folder outside the container, and then it would mount those folders here into the container. But that would be a really big and clunky command. So what you can use is Docker Compose. Docker Compose is a tool from Docker, which is usually used to start more than one container on your system. So when you are working on web services, for example, you want to start different services, so more than one container. And this is basically just a structured way to define this startup of the container, this Docker run command. I'm defining a container name. You don't have to do that. Otherwise, it's a random name. You have to define the runtime. I want to use the NVIDIA runtime, of course, and an entry point. So the entry point for us is the Jupyter Notebook. It's just the command that is executed when you start up the container. We want to start a notebook. Yeah, and then the image. This is my FastAI image, which I just created. And then the ports. So you have to forward the ports from inside the Docker container to your host system. And the 8888 port is the Jupyter Notebook port. So you have to forward it to your host system. Or restart always, you don't have to use that. And then here are all the folders that I want to mount into the container. So this FastAI code repository, it's is this folder here, and the Course v3 folder, of course, and the data folder. And also you can also mount files, single files. And I'm mounting the config file into the proper path on my container. So you have to define this, and then when you inside of this folder say docker compose run, docker compose run starts this file with the options you just gave it, and then you docker compose up, not run, sorry, starting the container. And as you can see, there is a notebook application running here, and when I go to my browser, just refresh it here, yeah, and that is the notebook server running on my inside of the Docker container on my workstation. So let's go into any notebook of the first lessons. Let's take the pet one and check if we have GPU support. So it's starting up the container. Let's just add a file here. I have the commands here. Check if we have GPU support. Import torch.
Kai, what theme is that? That looks fancy.
You can just Google dark theme. I forgot the name, but I really like dark themes because it's better for my eyes. And that's something that's stored in my in this config file I showed you. So
okay.
There you can make these options. And if I change anything in the options of the Jupyter Notebook here, it's going to be persistent because it's saved in the file that is outside in the on the host system.
Cool. I have to get that.
Let's have a look. I did not have a look into that. Which PyTorch version we have here? What is it? Torch.
Kai, a quick question from the chat, maybe. Okay. Sanyam was asking about slow internet connections, and that's probably a big no-no, right? I mean, the base images are always like multiple gigabytes for the.
Yeah. So pulling the images, there are multiple gigabytes, of course. Yeah, I guess there's no way around a decent internet connection to pull these images.
Yeah.
Yeah, so as you can see, inside of this NVIDIA PyTorch container, we have PyTorch 1.1, which is, I guess, one of the newest versions. Yeah. Okay, so I guess it's a lot of info if you never used Docker before, but if only 45 minutes, you have to give yourself a few hours if you want to really get used to it. There are plenty of tutorials out there. You can just check YouTube. You will find lots of tutorials for that. Yeah, are there any more questions?
There was another one from the chat. Did you need to git clone FastAI because you mounted in?
Yes. Yeah, of course. So you have to clone the course repository and the FastAI repository locally on your computer. And I already cloned it inside of the Docker file here because it's needed to install FastAI. When I am starting the container, it's going to be overwritten. So this FastAI folder is going to be overwritten by that folder that I have here. So when I pull the newest version into this folder and start it with this settings here and with the mounted volume, then it's going to be overwritten and the new version will be inside of the container.
Is your Docker file somewhere up in your GitHub?
I will post everything of this on Slack tomorrow.
Cool.
So I mean, this is really nice.
Yeah, no, yeah.
Really few lines you have to write for getting this up.
That's true.
Okay, so again, if you want to use it, you have to get used to it. You have to try some hours and probably have some fails. But for me, it was really worth it because. I mean, I have to do this one time here, and even if I have to completely refurbish my computer, I can use the same image because I just do Docker build this Docker file, and then I'll have it back.
Mm-hmm. Would you run multiple containers for multi-GPU stuff, like having one train and do the other stuff, or is that? That's
absolutely possible. That's absolutely possible. It's even a good way to do it because it's an isolated environment. You can even use different versions of CUDA parallel, but of course you have to assign a single GPU to each of the containers. That's possible. I do not have the. Sorry?
Negotiate which card gets assigned to which image, or do you have to have hardwire that?
I think you can define this. I do not know exactly how at the moment, but I'm pretty sure that you can define the GPU that is assigned to a Docker container.
Cool. Yeah.
All right. So, thank you.
Thank you.
Thanks, Kai. It was nice.
Yeah, great job.
I'll post the presentation and the stuff on the Slack channel, and yeah, see you next time.
Bye.
Bye.